Very good morning, students. Today we are going to see a behavioral diagram, that is state diagram, in details. State diagram can describe very complex dynamic behavior. The constructive core of the EML is class diagram, state diagram. Constructive core means that part from which an actual implementation could be generated. State diagram should only be used for objects with significant dynamic behavior. The basic elements of state diagram are, first of all, states. The state in which the object finds itself at any moment. Next is transition. Take the object from one state to another. Third is event. Cause the transition from one state to another. And next is action. Take place as a result of transition. Next is state machine. State machine diagram typically are used to describe state dependent behavior for an object. An object responds differently to the same event depending on what state it is in. Rambach defines that a state is an abstraction of the attribute value and link of the object. Sets of values are grouped together into a state according to properties that affect the gross behavior of the object. A state diagram may have a starting point and several endpoints. A state is a constant or a situation in which signals are asynchronous, that is, the sender does not wait until the receiver received the signal or reacted on it. Call event are synchronous. Now see here, asynchronous and synchronous messages are call event and signals, you can see. Next is a time event appears after the expiration of a time period, and change event occurs if a specific constant is fulfilled. The constant is a Boolean expression on the attributes of the actual object. Now here this transition line shows the movement from one state to other. Viewing a system is a set of states and transitions between states is very useful for describing complex behavior. Understanding state transition is part of system analysis and design. A transition is the movement from one state to other. Transition between state occurs as follows. An element is a source state, an event occurs or an action is performed, the element enters in a target state. So these are the transitions actually. Now same is here. You can see source state and target state, and here is the transition. When trigger or guard effect is there, transition is from source state to your target state. Then initial and final state. Now see, this is a black circle filled. Initially is the initial state, and circle within circle, black circle within a big circle is nothing but the final state. Now initial state is a state machine diagram of a state machine diagram known as the initial pseudo state is indicated with a solid circle, and final state is indicated with circle within a circle. So inner circle is solid. Composite state. Generally, composite state is defined as state that has substates or nested states. Substates could be sequential or concurrent. UML 2.0 denotes composite state as the state which contains one or more region. a state is not allowed to have both region and sub machine. Now see, this is a simple composite state in which customer authentication and transaction, these are the substates. Those are explained properly. So here is their start and end states also. Orthogonal composite state has more than one region. Each region has a set of mutually exclusive disjoint subvertices and a set of transition. A given state may only be decomposed in one of the two ways. It is called as direct substate when it is not contained by any other state. Otherwise, it is referred to as an indirect substate. Now see, here in this diagram, non-orthogonal composite state, you can see here substate 1 and substate 2, to and fro event, and event 3 when final state. Here composite state region only. So substate 1 and substate 2, and these two regions. Here also your initialization, then stop, and event 1, event 2 for the vice versa communication is possible. Same is here. Here is your submachine state. Now in the submachine state, actually it specifies the insertion of the specification of a submachine state machine. It is semantically equivalent to composite state. Region of the submachine state machine are the region of the composite state. Transition in the containing state machine can have entry or exit point of the inserted state machine as target or resource. The same state machine may be submachine more than one in the context of a single containing state machine. You can see here submachine state here. Now your ATM machine, verify card, read amount, verify transaction, and then card released. Now here your submachine states, they are shown out of service, aborted, accepted card. So this is all about the state machine diagram.